It's a mushroom basket design, the thing you do when you do consultation, right? So in the packaging industry, they had this challenge of this thin plastic mushroom basket that was stacking up during the manufacturing process, and you have some suction item wanted to extract just one basket out of the stack up to continue the manufacturing process. But because that basket wasn't stiff enough, the suction item was not able to extract only one because it was deforming too much. It was grabbing the neighboring basket, creating a jam in the manufacturing line, generating major delays, major costs. So the customer came to us and said, can you help us improve our basket design so it's stiffer, so we don't jam the manufacturing line? So we started with the flat surface, and we started with the Tosca Bead algorithm, which allows you to create shapes from a surface to maximize the design. From that Tosca Bead's result, we recreated a CAD using CATIA with this ribs shape. And these ribs were created with parameters, as you see here, the rib width, the draft angle, the height, and the number of ribs around each side. This is a quarter symmetry model, obviously. By doing that, we are able to then generate hundreds of different designs, and we use the process composer algorithm that now you're quite familiar with. Instead of a design of experiment, because we have a fixed objective, we are using an optimization algorithm. We tried actually two of them, the Hooke-Jeeves and the Adaptive DOE. And that optimization algorithm was driving the simulation object to study the stiffness. So we have few objectives. Again, we want to minimize the mass because we don't want to increase the amount of plastic too much and the mass of the basket, but we want to maximize the reaction force, meaning we want to maximize the stiffness. And we were able to generate hundreds of designs. Upon that as well, we tested some few features like a different rib design, or adding a shape in the corner, an edge to the step, a stacking feature, and so on and so on. In total, we generated nearly 300 design iterations of that mushroom basket. And by using result analytics, we've been able to make the data talk again and to choose the best design based on simulation data. And here we were able to find, for example, the run number 54, which was offering the best stiffness improvement by nearly 40%, but with an increase of mass of 4%, which is still a great result. But you can also don't choose the best one and look in the list and find, well, if you want to stay in the 2% mass increase, what is the best design? Well, we still have 34.5% improvement in stiffness with that design. So again, how long it would have taken you to study 300 analysis if you don't have these iterative automatic tools? I cannot answer, but that was a very powerful outcome for the customer, and now that mushroom basket might be in your fridge.